or three binary tree zigzag level order traversal from LeetCode. Let's jump to the question. The question is saying giving the root of a binary tree, return the zigzag level order traversal of its nodes values. So what it means by that, it means from left to right, then right to left for the next level and alternate between. So it means like we start from the root node, and it says we should start from left to right. So we start from left to right, and then we're going to traverse the tree like this, and then we're going to traverse the tree like that. So based on the tree that we have, we are going to have 3, 29 and 15, 7, which is left to right, right to left, and left to right, which is zigzag, right? And so we are going to, like, this is 3 levels, so 1, 2, 3 levels. So the output is list of 3 lists. And if we have only the root node, we're going to return 1. And if the tree is empty, there is no root node, nothing, so we're going to return an empty list. So let's jump to the solution and see how we can solve this problem. One way to solve this problem is using BFS. Another way is using DFS. We are going to use BFS here. For doing that, so as I mentioned, we are going to do it level by level. For fulfilling this purpose, what we can do is to do BFS. And for doing that, we need a final list that we put all the results in it and return it at the end, right? As you see, we return it at the end. One more thing that we need a list, because the output is list of lists, right? So we need a list that we can keep the nodes that we have in each level. But we cannot use a regular list because we are sometimes we are going from left to right, and sometimes we are going from right to left. And for DQ, we have this option to add the append to the left or append to the right, but the regular list just append to the right. So we are going to use DQ for that purpose. The other thing that we need like another DQ that we temporarily store the nodes in it. So this way we know if we are at the bottom of the tree and the last node, or we still have more nodes to traverse, right? And we need something to show us, like when we are done with the tree with one level, we need something to show us, okay, now you are going from left to right, now you should go from right to left. So we are going to use a flag for this purpose. We just consider when it's left true, and because we start from left to right as the question has suggested. So as I said, we are going to use a temporary DQ to store the all the nodes while we are traversing. So as long as this temporary thing is not empty, we're gonna go through this while loop, right? So at the beginning, we need to start with root node, and we have checked this condition here that we are sure the tree is not like empty, so we have a root node, because if it is empty, we just need to return an empty list and that's it. But now we're going to add the root to the temporary queue that we have, and none. Why we are using none? We are at the end of each level, we're going to add none, right? At the end of each level, we are going to add none. This way we can distinguish that we are done with one level, and we can add this level to the output and go to the next level and change the flag from true to false. When it's false, it means we are going from right to left, right? So what we are going to do is we start with the root node, and we're gonna pop it from the left which is going to be this one, and then we check if the root, if the thing that we have popped up from the queue, it's not empty, then we're gonna check the flag. If the flag is true, which means from left to right, we're gonna add at the end, and if the flag is false, we're gonna add at the beginning, right? If the flag is true, we're gonna add at the right side, and if the flag is false, which means it's from right to left, we're gonna add at the left side, right? And then we're gonna check if there is the node has any children, and if it has a left children or right children, we're gonna add them to the temporary list. And what will happen if we pop none? So we are not going to do this, we are going to do this. What we are going to do when it's none, it means we have done with one level, we are done with one level, right? So we are going to the next level, so we can add whatever we have in the level to the output. Plus we need to empty this level so we know there is nothing else in it, and then we can change the flag from left to right to left, or from right to left to right. And then we need to do one more thing. We need to check if the temp thing that we are keeping the level and all the other children's in it, if it is not empty, we're gonna add none, which means we are done with the next level. So you might be confused now. We will go through an illustration and you will better understand the question and the solution. As you see, we start from left to the right, right? We start from left to the right, right? And then from right to the left, and then from left to the right again, right? So let's run this illustration and see how it works. So at the beginning it is left, and we are going to add the root node and none, and then we're gonna pop that one and add it to the current, and see then we're gonna add it to the level, and then we're gonna go for the next one. And when we hit the none, we are going to put this one to here, empty the level, change the flag, and add a none here, right? And then we're gonna pop the next one, B, and then we are going to add it to the level based on the flag is right, and then we're gonna add the children, and we pop the next one, which is C, because it's right, so we are going to add to the left side of the node, and then we add the children. We pop none, so we need to move this to output, we need to empty this one, we need to change the flag, and we need to add none here, right? And in here we're gonna pop D here, and what we are going to do is we are going to add it to the level because it's from left to right. The next one is going to be added to the right side of the D, and then we are going to pop none because there is no children, so we are not going to add any more children, none. So we're going to add this, empty this one, change the flag to right, and done. We are done, and we can return it. So the whole process, as you see here, we are going to do it in only one while loop. So it's gonna be iteration over every single node. So the time complexity is going to be on, and the space complexity is going to be on as well, as we are storing every single node in the temp and level. So based on the number of nodes that we have, we are going to store them here. Thank you.